Hello children, now we will discuss the superset of a set. A set A is said to be a superset of B. There is a set A and another set is B. A will be the superset of B if B is a subset of A. B is a subset of A means every element of set A, every element of set B, every element of set B should be in A. B is a subset of A like 1, 2, 3, A, B, C, then so every element of set B is in set A. You can say B is the subset of A. Each element of B is an element of A. Then you can say B is the subset of A. Then A is known as the superset of B. Here is A is the superset of B. This is the sign of the superset. Sign of superset. Sign of superset. So set A is the superset of set B is here. To become a superset, there should be at least one or more than one element in A which is not in B. Then you can say A is the superset of B. Next we will discuss the intervals as subset of R. Okay. Now intervals as subset of R. R means real numbers. So let A and B be any two real numbers and A is less than B. We define four subsets of R which are called intervals. So first is closed interval. It is defined by AB. This is the closed interval means this is the signs of the closed interval. AB. Closed interval means A and B both are included. N is defined as AB. X such that A is less than equal to X is less than equal to B. Means both the elements are included. Means or you can say set of all real numbers from A to B. If we represent on a number line, see on a number line how can you? This is your A and this is your B because both are included and between them. So this is your portion which represents the closed interval. Means A and B both are included. For example, there is a closed interval 1 to 10. It means both are. That you can say X such that 1 is less than equal to X is less than equal to 10. Both the numbers are included here. So infinite elements will be there, including both this one only. So in closed interval, both we will be included. Open interval, we denote this one by like AB. This is the sign of open interval. Or sometimes we also write this is also the sign of open interval. It means this is X such that A is less than X is less than B. Remember, here is A and B are not included. If you represent on a number line, suppose this is A and this is B. So they should not be darkened. A and B are not included. This darkened portion is going to include. Here is we are going to dark A and B, so both are included and between them this is the portion. Both are and between this one. But here is A and B are not included, so they are not supposed to dark A and B is there. So open interval. Now there will be closed and open. Closed A, B and open. This can be, it means X such that A is included. A is less than equal to X but less than B. If we represent on a number line or it can also be written as sometimes this is A, B and this is also the open. That is X such that A is less than equal to X is less than B. And if you represent on a number line, A is included. A is included. So you are supposed to make it dark as here. A, but B is not included, not dark. This is the portion. This represents closed, open. Open, closed. Open, A, B, closed. It means X such that A is not included, so A is less than X, but B is included, so X is less than equal to B. Or it can be written as this is your open, not included, B, this is closed, is equal to X such that A is less than X, not included. A is less than X means X is greater than A, and but less than equal to B. But if you represent on a number line is here, so A is not included. So A is not dark and this is A. B is included. So you are supposed to make the B is dark. This one is there. So likewise you can written on the number lines also is there on it. So there are the four types is there. Closed interval, both are included. Both are included. Open interval, both are not included. Closed open, this is included but this is not included. Open closed is not included but it is included. Next we will discuss the power set. Now the power set. The set or family of all the subsets. Family of all the subsets of a given set A is said to be the power set of A and it is denoted by PA. Symbolically we can represent PA is equal to X such that X is the subset of A. So for example, suppose there is a set A, the element of set A is 1, 2, 3. We want to write the power set of A. So power set means that is the family of all the subset. So first is 5 will be included here because every set is the subset of every set, that is already discussed. And then 1, 2, this is A, 1 is the subset of this one, 2, 3, like 2 at a time you can take 1, 2, 1, 3, 1, 3, and then 2, 3, and then the set, because every set is the subset of itself. 1, 2, 3, this one. So this is your power set. 1, 2, 3 is the element of set A. So 5 is always the subset of every set. You know this one. Now 1 element at an element takes. This 1 is a set. This is an element for this PA, but it is a set in itself. So this is the subset of this one. Subset. Like 2 at an element takes 1, 2, 1, 3, then 2, 3. And then the set itself is there. So if we talk about NPA, then is equal to what? 1, 2, 3, 4, 5, 6, 7, 8. 8 elements are there. It means you can say in any power set, the number of elements in a power set will be equal to 2 raised to power n, where n is the number of elements in a set. Number of elements in a set. So look at here. Inside A there are the 3 elements are there. So how many subset will be in a power set? That 2 raised to power n. 2 raised to power n means 2 raised to power n is what? 1, 2, 3. So that is 2 raised to power 3 means that is 8. So you will see that 8 elements are here. 1, 2, 3, 4, 5, 6, 7, 8. So likewise you can find out the number of elements in any power set. And one more concept is also here. See, if A is the subset of B, if A and B are the two sets are there, but A is the subset of B, then PA will also be the subset of PB. If A is the subset of B, then the power set of A will be the subset of power set of B. So this is also one of the points there. Next we will discuss the universal set. Okay, now the universal set. Any set which is a superset of all the sets under consideration is called the universal set, and it is denoted by capital U. In few books you will see this is the sign they use for this, representing this universal set. In few books this is also one of the signs there. See now, this universal set is also known as a replacement set. You can say this is also known as a replacement set. Sometimes people are saying universal also, sometimes the replacement set is there. So for instance, suppose there is a set A, the element is 1, 2, 3. B's another set is A, B, C, 10, 20, 30. Set C we are taking suppose A, 1, 2, 100, 200 like this. Then any universal set is there. Then when this will be the universal set, if all the elements of these sets under the consideration, because these sets are taken, every element should be here. Like 1, 2, 3, 4, more than that also, 10, 20, 100, 200, A, B, C, D, E. Then you can say this is the universal because all the elements of sets A, B, C. The element of set A, B, C 1, 2, 3. 1, 2, 3 is here. Element of set B is A, B, C 10, 20, 30. A, B, C 10, 20, 30. Element of set C A 1, 2. A 1, 2. 100, 200, 100, 200. So all the elements are in this one. So you can say this is the universal set. To become a universal, that should be the superset. Superset is already discussed. Here is you will see that A is the subset of this universal set. Therefore, you can say the universal set is the superset of A. Similarly, B is the subset of this universal set. Then you can say universal set is the superset of B. Here is C is also the subset of this one, and this is also the superset for this one is there. So to become a universal set, if a set which is a superset of all the sets but under consideration, that is called a universal set, or you can say the replacement set. Next we will discuss few examples. Okay. Now one question we are taking. With the help of this question, we will try to understand the subset and belongs to here. See the example. If A is the set whose elements are 1, 2, 3, 1 inside the curly bracket, so this is the set in itself. And 1, 2, this is also the set in itself, but it is working as an element for the set A. This is also which is a set in itself, but an element for set A. State whether the following are true or false. So one important point is here only. Remember, number one, elements belongs to a set. Only the elements belongs to set. Element cannot be a subset of any set. Only set. Any set is a subset of a set. Set will be the subset of a set, but the element cannot be the subset of a set. So these things keep in mind. Element cannot be the subset of the set. So look at here. We want to know which one is true and which one is false. So what about this one is there? 1, 2. This is given inside the radicals. This curly bracket is a subset of A. It is true or false? This is true. Why it is true? See now. This is the element. It is already discussed. Element belongs, but we are saying this is the subset. But this is the element. This is an element for the set A, but set in itself. This is the set in itself. Because if, like one you are taking, one is an element, but if you are enclosing this one in a curly, then it is set. It is set. So this is an element for set A, but this element is a set in itself. Remember. So that's why it is true. Here is now this is as an element. This is an element belongs to A. So second one is true. Here. See now. This is the element. This is the element. Remember, look at here only. This is the element. This is the element, but it is a set in itself. So this will also will be the subset of this A. So this is also the true. Here is, see, this is a element. Look at here now. This is your element, but this is your element, but set in itself. Set is set in itself. Set in itself. So this is the element, but we are saying this is the set. A set never belongs. Element cannot be the subset of any set. Elements always belongs. Elements always belongs. Elements always belongs to any set. But elements cannot be any set cannot belong to A. So this is false. This is false. element, this is your element, belongs to A. So this one is true. So this is one of the best example to understand subset or belongs to. Remember, only elements belong to any set. Element cannot be the subset of any set. Or set cannot belong to or any set. Set means here we are taking now this is the element, but the set belongs to this one. This is the element is there. So forget this one. Remember this one is there only. So this is one of the best example to understand the belongs to or does not belong to or subset is there. One more example we will take. Okay. Now explain whether following statements are true or false. These 8 statements I have given. You are supposed to do at home. This is your homework to understand the belongs to or subset rest of the things, and you can send the answer in comment box to me. Okay, thank you.